Okay, so we're going to start trigonometry. It's one of my favorite things. Probably because I'm a math nerd, but I love it. And hopefully you will too. So it's pretty easy. Our learning target is I can find missing sides of triangles using trigonometry, and we're just going to focus on finding missing sides today. Okay, so first thing, let's talk about what is trigonometry. So trigonometry is the study of triangle measurement. So it sounds like a really scary word. It sounds like calculus. It's not. It's just the study of triangles and how you measure them, the sides and the angles. Okay, so we're going to talk about three different things: sine, cosine, and tangent. These are super important when we start talking about trigonometry. These are going to be our three main trigonometric ratios. Okay, so sine, anytime you talk about that, that's the ratio of the leg opposite the angle to the hypotenuse. Here's what I'm talking about. If I'm talking about the sine of angle A, here's angle A. The side that is opposite A is little a divided by the hypotenuse C. So it's just a fraction. It's the opposite divided by the hypotenuse. If I do angle B, my opposite leg is now B. My hypotenuse is still the same. So B over C. Alright, cosine. Cosine is the ratio of the leg adjacent to the angle to the hypotenuse. So cosine talks about adjacent and hypotenuse. So if I look at angle A, I know that this is my hypotenuse because it's the longest side. The adjacent side is the one touching it. So B. See how B is touching angle A? So if I do my ratio, the adjacent side, B, divided by C. Alright, if I find the cosine for B, my adjacent leg is this one, A, because it's touching it, but my hypotenuse is still C. Okay, and last is tangent. So tangent is the opposite, the ratio of the leg opposite the angle to the leg adjacent to the angle. Okay? So if you look at angle A, the opposite side is A, and the adjacent side is B. A over B. If you're looking at angle B, your opposite side is B, your adjacent side is A. So tangent is the only one that doesn't deal with the hypotenuse. Okay. So it's kind of hard to remember. So let me show you one more picture and see if it makes sense figuring out which one the adjacent, the opposite, and the hypotenuse are. Okay, so if you look at this picture, it's a silly little picture, but sometimes it helps. So the angle in question is X. Alright? The side opposite from X is this one over here, A. So opposite is directly across from it. The side that's touching X is the adjacent side. So this one. So that's B. And then always across from the right angle is your hypotenuse. And it has to be the longest side so the hippo can fit on it. It's a silly little picture, but it does help. So anytime you look at a triangle and you're talking about right triangle trig, the three sides are going to be opposite, adjacent, and hypotenuse. And you have to know which one is which. So opposite is always going to be across from the angle you're referring to. adjacent is going to be touching the angle we're referring to, and the hypotenuse is the longest side across from the right angle. Okay, so sometimes people will call right triangle trig SOHCAHTOA, and it comes from this little mnemonic device. And it's just a way to help you remember the ratios. Okay, so SOH, the sine is equal to the opposite divided by the hypotenuse. So that's what SOH stands for. The cosine ratio is your adjacent side divided by your hypotenuse. CAH, cosine adjacent over hypotenuse. And tangent, the TOA, is your opposite divided by your adjacent. So you can remember those three trig ratios and how to set them up if you remember SOHCAHTOA. Here's what people usually remember. Alright, so if you remember the same, some old hippie, that's your SOH, opposite over hypotenuse. Caught another hippie, that's your CAH, cosine is adjacent over hypotenuse. Tripping on acid, that's your TOA. Tangent is opposite over adjacent. So if you can remember SOHCAHTOA, or you can remember some old hippie caught another hippie tripping on acid, you'll remember how to set up these ratios. Okay, so we're going to practice this. Okay, so we're going to do this side first, because if you'll notice, they're all talking about the same angle A, so it'll be a little bit easier for us. Okay, so sine, remember that's some old hippie. So sine is your opposite over your hypotenuse. If you look at angle A, the side opposite from A is 5 divided by the hypotenuse is the longest side, 13. Alright. Alright, so if I want to do cosine, remember that's caught another hippie. Cosine is my adjacent over my hypotenuse. The side that's touching A is 12 divided by hypotenuse, 13. And then last, we have tripping on acid. Tangent is opposite over adjacent. So my opposite side is 5, my adjacent is 12, so 5 over 12. Alright, so it's just a fraction. It's how an angle relates to two sides. Okay, so now we're going to do these three. Notice we never use the right angle. We're only going to use the other two angles. So this time we're looking at C, but our trig ratios are still the same. So if we find the sine of C, my opposite is now 12. Hypotenuse is still 13. When I do cosine, that's my adjacent over my hypotenuse. My adjacent is 5, because that's the side that's touching it, divided by 13. And then when I do tangent, tripping on acid, opposite over adjacent. Opposite from C is 12, and adjacent to C is 5. So that's how I'm getting these measures. Okay, so I want you to try this one first. So I want you to look at W. Remember, some old hippie, sine is opposite over hypotenuse. Call another hippie, cosine is adjacent over hypotenuse. Tripping on acid. Tangent is opposite over adjacent. I want you to see if you can fill these in. Try this in 1, 2, 3. Okay, so first thing I want you to realize is that your hypotenuse is not given, but we're talking about a right triangle, so we can set this up very quickly. Alright, so 81 plus 144 plus x squared. I get 225. If I take the square root, I get 15. So, very quickly, you can find the hypotenuse. And now, should be fairly easy. So, sine of W is 12 divided by 15. Cosine of W, 9 over 15. And tangent of W, 12 over 9. So, now see if you can do x. So it changes just a little bit. So try it in 1, 2, 3. Alright, so sine is now 9 over 15. Cosine is 12 over 15. And x is 9 over 12. So we're just practicing writing the ratios. Alright, let's do this one. So first thing I want you to do is I want you to use Pythagorean theorem to figure out what that other side is. Try that in 1, 2, 3. Okay, so if you set it up correctly, you should have got 30. And now I want you to look at L, and I want you to write the 3 trig ratios for L. 1, 2, 3. So the sine of L is 30 over 34. The cosine of L, 16 over 34. And the tangent of L, 30 over 16. Okay, now I want you to pause the video and do it for M. 1, 2, 3. M is 16 over 34. Cosine, 30 over 34. And tangent, 16 over 30. Okay, so hopefully that was enough practice with just setting up the ratios. Because now we're going to set them up and we're actually going to find some stuff. We're going to find some missing side lengths. Alright, so whenever we do this, we want to make sure that our calculator is in degree mode. So if you are using a TI-84 calculator, you want to go to mode, and where it says radian, you want to just select degree right beside of it. If you're using just a scientific calculator on the computer, you can change the mode. Just make sure it's in degree. Okay, so we're going to do number 1. Alright, I'm referring to this angle 28 because that's the one that's labeled. I'm talking about this side and this hypotenuse. So I know that this is my hypotenuse. And then x is either going to be my opposite or my adjacent. So 28 and x are opposite from each other. So when you think about Sakatoa, someone hippie caught another hippie tripping on acid, the only one that deals with opposite and hypotenuse is sine. So that's why we're going to use sine. So the sine of the angle equals opposite over hypotenuse. So that's why we practice setting up those trig ratios. Alright, so the next thing I want you to do is type sine 28 in your calculator. Okay, so when you do that, it's just a number. So I want to show you a little trick. We want to get x by itself. Right now it's being divided by 19. So if I multiply both sides by 19, what's going to happen on the right side is that's going to cancel out. So 19 times sine 28 is just a number in the calculator. I want you to type all of that together in your calculator, and we're going to round to the nearest tenth, and you'll notice you get 8.9. So that side over here, x, was 8.9. That's how you use trig to find missing sides. So let's look at number 2. We are referring to this angle 41. X is directly across from 41, so that's our opposite side. And 32 is touching 41, but it's not the hypotenuse, so that's our adjacent. Okay, so the only trig function that deals with opposite and adjacent is this one right here, tangent. So here's how you set it up. The tangent of the angle equals opposite over adjacent. Okay, so we're trying to get x by itself. It's being divided by 32. I'm going to multiply both sides by 32. When that happens on the right side, that cancels out. So 32 times the tangent of 41 is what x equals. And when I put that in my calculator and I round to one decimal place, I get 27.8. So this side right here is 27.8. So that's how you use trig to find missing sides. Okay. We're going to try these as well. Number 3, I'm talking about 21. This is my hypotenuse, and this is my adjacent. Sakatoa. The trig function that deals with adjacent and hypotenuse is this one in the middle, cosine. So the cosine of the angle equals the adjacent over the hypotenuse. Once again, trying to get x by itself. So in order to undo dividing by 26, I'm going to multiply both sides by 26. So 26 times the cosine of 21 equals x. I put that in my calculator and I get 24.3. I look at number 4. I'm talking about 55. 8 is touching 55, but it's not the hypotenuse. And then x is directly across, so it's the opposite. And the only trig function that deals with opposite and adjacent is my tangent. So tangent of the angle equals opposite over adjacent. I want to get x by itself. I'm going to multiply both sides by 8. This cancels out. So 8 times the tangent of 55 is going to be what x equals. And I put that in my calculator and I get 11.4. Okay. Alright, so let's look at these. These are going to be a little bit different, but not too bad. So let me write Sakatoa up here. I'm talking about this 33-degree angle. 15 is directly across. That's my opposite. X is across from the hypotenuse. From the right angle, which makes it the hypotenuse. And the only trig function that deals with opposite and hypotenuse is my sine. So the sine of the angle equals opposite over hypotenuse. Okay, so this function has changed because we are dividing by x. So the only thing that we can multiply by would be x. So that's different from those first 4 problems we did. This cancels out, so we get x times the sine of 33 equals 15. Remember, the whole point is to get x by itself. So I need to get rid of sine 33. It's being multiplied. The opposite of multiplying is dividing. So I'm going to divide by sine 33. So if I put this in my calculator, 15 divided by the sine of 33 is 27.5. Alright, look at number 6. I'm talking about 43 degrees. This is my adjacent side. This is my hypotenuse. So I have to use cosine. Cosine of the angle equals adjacent over hypotenuse. Once again, x is on the bottom, so I'm going to have to multiply by x. Then, to get rid of cosine 43, I have to divide both sides by cosine 43. And when I put that in my calculator, I get 49.2. Okay. Alright, so I want you to try these two on your own. I want you to pause the video and try it as hard as you can in 1, 2, 3. Okay, so here's how you set this up. But these two problems are very different because, notice in the first one, x is on the bottom. So I have to multiply both sides by x. Just wrote the wrong number. But on the second one, I have to multiply by what I'm dividing. So that's why I'm multiplying by 11. So hopefully you can pick up on that difference. Alright. So also in the first one, I got to get rid of tan 72. So that's why I'm dividing by tan 72. Alright, so for number 7, if you did it correctly, you should get 8.1. And for number 8, if you do it correctly, you should get 4.8. If you need further explanation, let me know. But we're going to move on for right now. Alright, and we're going to do these two application problems. So I want you to practice visualizing what the problem is. I want you to pause the video and I want you to draw a picture of the situation. Obviously, you need to be making a right angle somewhere. So try both of these in 1, 2, 3. Okay, so here are the two pictures. So now see if you can figure out which trig functions to use and set it up. Try this in 1, 2, 3. So this is how it should be set up. And now I want you to see if you can solve them. So notice number 9, x is on top. Number 10, x is on the bottom. So you're going to solve them in two very different ways. So try it in 1, 2, 3. Alright, so hopefully you got number 9 was 4.5 and number 10, 16.6. If you have any extra questions, let me know. Try your assignment, and hopefully you like this, because I do. I think it's a fun unit. Fun as far as math can be fun. Alright, I'm just blabbing, so bye.